Here we're given f prime, in other words, we're given dy by dx, and we're asked to find f of x. So therefore we'd need to integrate this to find f of x. Now we call this a particular solution because we're not going to integrate and then add a constant. We're actually going to find that constant because we are given the coordinates of a point that the curve passes through. So there's several steps. We need to integrate, we need to substitute the coordinates we have to find the constant c, and then we're going to rewrite what we have as a particular solution. So let's make a start. Now, if you look at the question, finding this integration is easy, finding this is less easy. So I'll start the question off by saying f of x equals the integral of f prime of x. So if you integrate the derivative, so the integral is the inverse of the derivative or the antiderivative. So we can integrate this to find f of x. So now I'm going to substitute that in there. So the integral of 8x minus 3 over 3x minus 2 squared dx. So integrating f of x, so 8x, is not a problem. Integrating this is slightly less obvious. So let me remind you of something we call the reverse chain rule. So the reverse chain rule, we could also use substitution, but the reverse chain rule makes it a little faster. So the reverse chain rule is where you have some function, so the integral of f of x raised to some power n dx. But that function f of x is multiplied by its derivative. So we have f of x multiplied by the derivative of f of x. When we have a situation like that, the integral then looks something like this. The actual answer looks like this: f to the power n plus 1 divided by n plus 1, just as if it were x. So this is the reverse chain rule. So whenever you have a situation where you have a function raised to a power multiplied by its derivative, we can ignore the derivative or cancel the derivative and simply raise the function to the power n plus 1 and then divide it by the new power. So that's our reverse chain rule, and I'm going to apply that to this integral here because it looks like the derivative of 3x is 3, so we can apply the reverse chain rule quite comfortably. So let's not confuse this f of x with this f of x, but let's rewrite this as something a little bit more sensible. So if I say f of x equals the integral of 8x minus 3 times 3x minus 2 to the power negative 2 dx. So I'm allowed to do that. I'm allowed to bring the denominator up to the numerator and put a negative sign there. So now here, the derivative of this is there. So I can use the reverse chain rule and simply add 1 to this power. So this integral f of x equals, this is straightforward, it's simply 8x squared divided by 2. But then immediately I can say this is minus 3x minus 2 to the power minus 2 plus 1 divided by minus 2 plus 1 plus c. So I've applied the reverse chain rule here. Negative 2 plus 1 is negative 1. So I can write it like that. And dividing by minus 1 is the same as multiplying by minus 1. So we might as well just change that sign to become a plus. So that now is f of x. That's what the question asked for, find f of x. But they gave us this point, minus 1, 3. So I can use that, that given point to find the value of c, because minus 1 is my value for x, that I can substitute in there, and 3 is my value for f of x. So I can now find c. So I can say 3 equals 8 divided by 2 is 4, so that's 4 times minus 1 squared, plus 3 times minus 1 minus 2 to the power minus 1 plus c. So 3. So all I've done is replace x with negative 1. So every instance of x is negative 1 and y with 3. So 3 equals 4 plus negative 3 minus 2 is minus 5 to the power minus 1 plus c. So 3 equals 4 minus 1 over 5. So that minus is there, and that brings your 5 down to the denominator, plus c. So 4 minus 1 over 5 is 3 4/5. So we can now say c equals 3 minus 19 over 5 equals negative 4 over 5. So now we've found the value of c. That's really helpful because that's what we can put in there, or at least in there, with our new expression for f of x. So I can rewrite as f of x equals 4x squared minus 3x minus 2 plus c. And instead of c, I'm going to put negative 4 over 5. So this here is my value of c. And the question asked to find f of x. This is f of x now. So this is my final answer. I can put that in a box and call that my final answer. So this is called the particular solution, because what we found has no unknown constant. We found the value of c, so it's called the particular solution. Whereas what we had found earlier here, that is called the general solution, because we still don't know the value of c. So this is called the general solution. So just as a recap, how did we answer this? We first integrated this, and we needed to use the reverse chain rule. After doing that, we substituted the coordinates that we were given in f of x and x. We rearranged to find the value of c, and then we put the value of c into the general solution to find something that we call the particular solution. So that's the value of f of x.